Okay, we're graphing systems. Y'all have done systems before. Systems is not new. Y'all did them, I know for sure, in Algebra 1, and I'm almost positive you did them in Algebra 2. So it's not new. Systems of equations is just when you're looking at two or more equations solved together. Okay. Your solution is where the lines touch / intersect. It's where your X and Y match. Okay, I know I said two or more equations. Just know that in here we're only looking at two equations at a time, so don't let that or more freak you out. So if you look at number 1, it says we're determining whether the ordered pair is a solution to the system. So the way we know, if I'm given an ordered pair and I'm asked, is it a solution to my system, we're going to make life easy and we're just going to plug it in and see if it's true twice. Okay, so when I plug this in, this is my X and my Y. So I'm going to rewrite this as 2 parentheses X is 12 minus 3 parentheses Y is 6. And I want this to equal 6. And we're going to use our calculator. 2 times 12 minus 3 times 6. Did it equal 6? Yes, so this is a solution to this. And when I plug it into the second one, well, X is 12 equals 2 times Y is 6. What's 2 times 6, y'all? Did it work? So this is a solution. Because it was a solution to both equations. Are we okay with that? Okay, so if we look at this one, same concept. X is -1, Y is 2. So we're still going to use our calculator. And that one worked. It gave me 3 equals 3. And this gives me -6. Is that true?
No.
No, because -6 does not equal +6. So this is not a solution to the system. Any questions with part 1?
No.
Okay, so let's look at part 2. Now we're going to talk about our kinds of systems. So our first kind of system is when our lines have different slopes. And it's going to look something like this. So they have different slopes. And our y-intercept doesn't really matter because technically, could the y-intercept be the solution?
Yeah.
Yeah, so the y-intercept, good lord, could be the same or different here. It doesn't matter as long as the slopes are different. And so your solution, we're just going to guesstimate, is like -1, 2. And our kind of system, KOS, is independent and consistent. It's independent because they're different lines, and it's consistent because there's a solution. There is a spot where they're the same. Now, are we going to write that every single time? No. So we'll just write I and C, and I'll accept that. As long as you understand it means independent and consistent. Our next example looks like this. Now, what does that mean? What's happening? They're the same. We have the same slope and the same y-intercept. So my solution is IMS, infinitely many solutions. Okay, and our kind of system here is dependent and consistent. So we'll use D and C here. Dependent because aren't the lines exactly the same?
Yeah.
And consistent because there's still a solution. So anytime there's a solution, it's consistent. If they're different, it's independent. If they're the same, it's dependent. Okay? And our last type of problem is going to look something like this. What do you notice? They're parallel. They have the same slope, but they have different y-intercepts. So when it's the same slope, same y-intercept, it's a special case. And when it's the same slope, different y-intercept, it's a special case. Because if they never touch, what's your solution?
Nothing.
There is no solution. And we call this, oh God, of course it is. I think this is my charger. I'm just gonna have all the cords. Maybe it's better? I don't know. We call this inconsistent. Okay, which you could just use a capital I for. And it's inconsistent because there are no solutions. Any questions with that? Okay, so let's look at the next part. We're not actually going to go all the way through the next part because it's a lot, but we're going to talk about it. I'm about to sneeze. Maybe not. Okay, so my first equation is 1/2 x minus y equals 2. And okay, it says, so part 3 says find the number of solutions without graphing by paying attention to slopes and intercepts. We'll define slopes and intercepts that either needs to be in standard form or slope-intercept form. This is not technically standard form because it has a fraction. Standard form never has fractions. So we can get y by itself. I prefer y by itself because doesn't this give me my slope and my y-intercept when y is by itself? Yes, the correct answer is yes. Okay, so I don't usually tell you to move what you're solving for, but here I have this minus y and I don't want to deal with a negative y. So I'm going to add y to both sides. Now that I have y over here that's positive, what do I need to do with it? What do I need to get rid of to get y by itself?
Minus 2. Yeah,
I'm going to subtract 2 from both sides. That cancels, and I have 1/2 x minus 2 equals y. Well, is y by itself?
Yeah.
So now it's in slope-intercept form. What's my slope?
Oh, 1/2.
1/2. And what's my y-intercept?
-2.
So now if we look at this other equation, we have x equals 2y plus 5. Again, it's not in standard form, and it's not in slope-intercept form, so let's get y by itself. What do I want to move? I'm going to add, so I'm going to subtract 5 from both sides to get rid of that plus 5. So I have x minus 5 equals 2y. Now what?
Divide 2.
Yeah, divide everything by 2. And technically this is 1x, y'all, so divide, divide, divide. And so I have slope is 1/2, I have my y-intercept is negative 5 over 2, which is a decimal. Now, what do we notice about my slope and my y-intercept for the 2? Well, my slopes are the same. Are my y-intercepts the same?
No.
No, so the same slope, different y-intercept, and what does that mean? When they had the same slope, different y-intercept,
No solution.
there was no solutions. There's 0 solutions here. Does that make sense? Now, I'm going to help you find one of these slopes, and then we're going to be done with this section. Okay, when it's in standard form, do y'all remember that slope is opposite of a over exact b? So aren't these in standard form where x and y is on the same side? So a, b. So my slope for that first one is opposite of a over exact b, which is just 3. What's my slope for the second one? Negative 1/2, right? Opposite of a, there's nothing there, so it's a 1. So negative 1 over exact b is 2. Do 3 and negative 1/2 match?
No.
So what's the only one that has a different slope? How many solutions does this one have? Because that's what it's asking, is how many solutions. So this one's going to have 1 solution because they have different slopes. Does that make sense? Do y'all see what this is asking? Okay. So flip to the back when you're done writing that down. We're going to actually graph now. We're done with the little stuff. Okay, we're actually not going to do example 5, so you can cross that out. It's a bad, terrible example. Okay, so we're here. Just a reminder, these are reminders to find x-intercept when it's in standard form, y'all. This is from standard form. So when it's in x and y are on the same side, this is what you do. So plug y equals 0, plug in y equals 0, and solve. So for y-intercept, you're going to, hello.
Across the hall. I can wait out here while you finish up.
Okay.
But I just want to let you know.
Yeah. We'll let her in. So on this one, you're going to plug in x equals 0 and solve. Okay, what does HOI stand for? Who remembers? Somebody let him in. 0 slope. Y equals a number, no x. Thank you.
Very easy.
Okay, what does VUX stand for? X equals a number with no y. I knew it was coming.
Salute.
Thank you. Okay. And there is one mistake that before I remember, forget, make this a plus 2x. I'm just, I'm really good at math, so. As I teach y'all math. Okay. Example 1. Solving by graphing. Okay, by the end of this unit, I'm teaching you 3 different methods to solve systems. And when you're graphing, the best time to do it is when you have 2 y equals equations, because you can plug them in, right? Graph them super simple. That's why we'll use this method. Now, I will tell you sometimes whenever you have standard form and a slope-intercept form, you'll still graph. But there's another method to do on this one that we will learn later. Okay, but for now, we're focusing on number 1. We like when it's y equals. Now, if you're not good at graphing, can you type this in your y equals and plot points?
Yeah.
100%. I don't like doing that. I feel like it takes longer. I think it's easier just to look at it. Your y-intercept is the number by itself. So this is my y-intercept. And this is because y is by itself. That's why I can look at this and know. So -1 is my y-intercept. So on my y-axis, I'm going to put a point at -1. And what's my slope? 2 over 3, and it's positive, so I'm going to rise 2, run 3 to the right. So from that point, I'm going to go up 2, 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And then I'm also going to do down 2, backwards 3. Remember, you can do opposite, opposite, and it still follows the pattern. Now on that first line, you're going to go pretty much all the way across because you don't know where the solution is. You don't know if it's in the middle. You don't know if it's this last point we just plotted all the way over here. We don't know. Does that make sense? And you don't want to graph half of it and then have to go back and graph the rest of it. Now on that second equation, plot at least 3 points, yes? At least 3. So my y-intercept is what?
2.
So positive 2. And what's my slope?
-1.
-1/3. If the negative's in the middle, y'all always give it to the top. Okay, so that means I'm going to go down 1, right 3. Well, don't I just find my solution right away?
Yeah.
Down 1, but put a third point just to be safe. If I can count. Good Lord. Okay. And what's my solution? How far to the right is it?
Oh, it's like where they meet.
Yeah? 3, and how far up? So 3, 1 is my solution. And kind of system, so KOS is independent and consistent because they're not the same line, but they do have a solution. Any questions with that? Okay, look at example 2. Y equals x. What's your slope on this one? Not slope. 1. If there's no number, it's a 1. So my slope is 1 over 1. But I need to know where to start. Does it have a plus or minus?
No.
What can you add that changes nothing?
0.
0. So 0 is your y-intercept. So that just means it goes to the origin. Y'all, if it doesn't have a plus or minus, but it has an x and a y, it just means it goes to the origin. So my slope is rise 1, run 1. And it just means you're going up 1 over 1, up 1 over 1. You can also go downwards, backwards 1. And then what about this second equation? Is it a special case? Yeah, it's a VUX. Vertical undefined x equals equation. So we're going to draw a vertical line where x is -3. This is my x-axis, so x is -3 here. And here's my vertical line. I know mine is perfect. That was a joke. Where do they touch?
-3.
-3. And my kind of system, again, is independent and consistent.
When is it independent and consistent?
Anytime there's one solution. And here is my solution.
Got it.
Okay, on this one, I'm going to graph the easy one first that has y by itself. What's my y-intercept?
2.
2. And what's my slope if it's not a fraction?
It's 2.
2. I don't know why I put equals, sorry. M equals 2 over 1. So I'm going to rise 2, run 1. So there's that line. Now my other one is in standard form. I can find my slope by doing opposite of A over B. What's the opposite of A?
A -8.
Over exact B.
-4.
And that simplifies to 2, which is just 2 over 1. So I know I'm going to rise 2, run 1. But I don't know where I'm going to put that because I don't have a point. Do y'all remember when we did standard form and I would say, does 8 go into 12 pretty? No. Does 4 go into 12 pretty?
Yeah.
What letter's touching 4?
Y.
Y, so that's what we're solving for, is the y-intercept. So y-intercept is where x equals 0. So we're going to plug in x is 0. Well, doesn't anything have 0 cancel?
Mm-hmm.
So how do I solve this for my y-intercept?
Divide.
Find negative 4. And what does that equal?
Negative 3.
So there's my y-intercept. My slope is rise 2, run 1. Rise 2, run 1. Rise 2, run 1. What happens? They're parallel. Why are they parallel? Because they have the same slope, different y-intercept. So my solution here is no solution. My kind of system is inconsistent. Any questions with that?
No.
Okay, the last graphing one is actually super simple, so don't. We're almost done, I swear. Okay, so look at example 4. One of them has y alone. Does this one have y alone? What do I need to do to get y alone? Add 5. When I do that, what do I notice about my two equations?
They're the same.
What's the intercept for both? Positive 5. And what's my slope for both?
Negative 3.
So I know my intercept is 5. And I know my slope is negative 3 over 1. So down 3, right 1. Yeah. So I'm going to put at least 3 points. And when it's the same line, y'all, please do the double arrow so I know that you understand what's happening. So what's my solution? IMS. And what's my kind of system? Dependent and consistent. Dependent because they're the same, and consistent because there's a solution. Okay, so this is what you're working on. One thing I do want to help you with really fast on the key, on the answer, is because we didn't do 5, if you look at the back, I'm just going to help y'all come up with the equations on 13.
Oh, we have to make our own.
Yeah, I'll tell y'all, the one on the notes was way harder than the one on the practice. So that's what I was like, I'm not. Okay, so it says rent your car charges a flat rental fee of $50 to rent a car and charges an additional $5 per day. Do y'all remember the words each, every, and per tell you where your slope goes?
Yeah.
Okay, so I know that equation 1 is my rent your car. I have to pay $50 plus $5 per day to figure out my total cost. So X is my number of days, because it said per days, and Y is going to be my total cost. Okay, the next one says budget rental charges $15 per day, so 15X, with no initial fee, so there's no plus or minus, and that will equal your total cost. All right, so that's all I'm going over on that one.